On November 5th, 2025, two new images of the interstellar object 3I Atlas were released by the Virtual Telescope Project, and what they revealed left the scientific community even more perplexed. The photographs show Atlas as a compact source of light, with no visible cometary tail. Even more astonishing, the object's appearance remains virtually unchanged since the Hubble Space Telescope observations in July 2025. According to Harvard astrophysicist Dr. Avi Loeb, this is deeply problematic. An object that should have lost at least 13% of its total mass, over 5.5 billion tons of material, shows no sign of a massive coma. That absence is inexplicable. To put this into perspective, the same images also captured Comet Lemon, a typical solar system comet, clearly showing a bright tail pointing away from the sun, formed by solar radiation pushing gas and dust into space. In contrast, Atlas remains mysteriously clean, without any of the visual signatures that should accompany the immense material loss required to explain its non-gravitational acceleration. According to Loeb, this is yet another indication that Atlas is not behaving like any natural object we've ever observed. And that leads us to a fundamental question science can no longer ignore. Non-gravitational acceleration. Something else is pushing it. There's been a lot of misinformation and alarmism about Atlas and its acceleration. Let's look at the actual data. On October 29th, at its closest point to the Sun, Atlas began accelerating in a way that gravity alone can't explain. NASA's Jet Propulsion Laboratory released a report showing Atlas was 4 arcseconds off from where it should be based on standard gravitational calculations. That may sound small, but at a distance of 203 million kilometers, it represents a deviation of roughly 80,000 kilometers in just 1 month. This acceleration has two components: radial acceleration away from the Sun, what I 135 kilometers day 2, 60,000 kilomonth; lateral acceleration, sideways drift, 60 km day 2, 127,000 kilomonth. This means Atlas isn't just drifting in one direction. It's being pushed both outward and sideways at the same time. But let's be clear, this is not a threat to Earth. The object's deviation doesn't alter its trajectory toward any planet except Jupiter, where it's expected to arrive in March 2026. The outgassing problem. Where's the gas? For comets, outgassing is the most accepted cause of non-gravitational acceleration. As ice sublimates near the Sun, it turns into gas and escapes, pushing the comet like tiny rocket thrusters. But here's the problem. To account for the observed acceleration, Atlas would need to lose 5.5 billion tons of gas in just 1 month. That would create a huge bright cloud, a coma, visible to any telescope. And yet, no such coma has been observed. Dr. Loeb did the math. Atlas has a mass of at least 33 billion tons, with a nucleus estimated at 3.5 miles, 6 kilometers across. That makes it 1,000 to 1,000,000 times more massive than Oumuamua or Borisov. The amount of gas required to push something that large should be visibly overwhelming. From late November 2025 to late January 2026, dozens of ground-based observatories, Hubble, James Webb, and others, will track Atlas. On December 19th, it makes its closest approach to Earth at 167 million miles. If that gas is there, we'll see it. But if it's not there, the natural explanation fails, and we may have to consider something technological. This isn't the first time. The case of Oumuamua. We've seen this before. In 2017, the first known interstellar object, Oumuamua, also exhibited non-gravitational acceleration, without any visible signs of outgassing. Even the Spitzer Space Telescope couldn't detect gas or dust. Scientists were baffled, eventually calling it a dark comet, an oxymoron, as comets must have a tail. But Atlas is even stranger. It's showing additional anomalies that stretch natural explanations to the breaking point. 9. Astonishing anomalies that challenge everything. 1. Impossible path. Atlas approaches the Sun at just 5 degrees from the ecliptic plane, where all planets orbit. The odds of a random interstellar object arriving from this precise angle? 0.2%. 2. Jet toward the Sun. In July-August 2025, Atlas ejected material toward the Sun, violating physical laws. All known comets eject material away from the Sun due to solar radiation pressure. 3. Too big, too fast. Despite being enormous, Atlas moves faster than smaller interstellar objects. Larger bodies should move slower, not faster. 4. Suspicious timing. It passed close to Mars, Venus, and Jupiter, but avoided direct visibility from Earth during perihelion, its most active moment. 5. Factory composition. Spectral analysis shows much more nickel than iron, a ratio typical of industrial alloys, not natural space rocks. 6. Dry as stone. Natural comets are 80–90% water ice. Atlas, just 4%. That's drier than Earth's deserts. 7. Unknown polarization. It reflects light in a way no other natural object ever has. It's a light fingerprint that doesn't match any known material. 8. WOW signal connection. Atlas came from the same region of the sky as the famous 1977 WOW signal, a possible candidate for alien communication. Coincidence? 9. Bluer than the Sun. Its glow is bluer than the Sun, suggesting a surface temperature or energy output higher than 5,800 K, which is physically impossible for a passive object. What if it's not a comet? Let's be honest, scientists are not saying this is alien technology, but they are saying that the data demands investigation, not dismissal. Dr. Loeb warns against ignoring inconvenient facts. As he put it, you can't reject data just because you don't have a theory to fit it. Atlas forces us to ask, what kind of object behaves like this? What kind of physics are we witnessing? Countdown to contact. As we approach December 19th, telescopes across Earth and space will be watching. If we don't see the 5.5 billion tons of gas that should be there, we may be witnessing the first confirmed alien artifact ever observed. A technological object using advanced propulsion entering our solar system. And for the first time in history, we might not be alone.